Thank you for joining us. We wanted to go over the way slenderness is specified for columns in the EnterCalc Structural Engineering Library column programs. Let's start out with a wood column. Here we have a column, we're using a 2x6 column. And the 1.5 inch dimension is called the width, and the 5.5 inch dimension is called the depth. Notice the x-axis is parallel to the small dimension, or the width dimension. The y-axis parallel to the depth dimension. In steel and timber design, we're concerned with lateral torsional buckling of the column and also column slenderness. Now, a lot of people specify bracing. They say, well, the column is braced for major axis bending or minor axis bending. That has proven to be a very general term. In EnterCalc, what we do is we specify the distances between braces, bracing the column against movement along a particular axis. So if this were a cross section of a wood member, of a wood joist spanning maybe 10 feet, if this was unbraced and this was the compression edge, for lateral torsional buckling to take affect the allowable stresses, the top of this member would have a tendency to buckle sideways if it wasn't laterally braced. And so what is required to keep that from moving laterally is a brace along the x-axis, basically pushing the member back into place so that lateral torsional buckling doesn't occur. And so the way EnterCalc specifies this is that we have a brace preventing x-axis local buckling or local movement. So you'll see up here this tab, x-axis column slenderness. X-axis refers to this axis where if the buckling is occurring, it's going to occur because of movement of the column along the x-axis laterally, whether by failure in bending, moving along the x-axis this way, or for column buckling, moving along the x-axis. And so for this member, you obviously need greater bracing along the x-axis because it's so slender. Along the y-axis it isn't so great. So first of all, let's go to the y-axis and tell it its unbraced length. It's unbraced for 12 feet. We'll go back to the capacities. Well, the column is still okay because you have a 2x6. The bracing, it's unbraced the full length, and so the column is free to move along the y-axis. The full unbraced length is 12 feet. If we brace that, we come over to the x-axis and we say, okay, this column is free, it's completely unbraced for 12 feet along this x-axis. You know, oh my gosh, we get all these warning messages. That's because the column has no bracing along its slenderness, its x-axis, meaning there is no brace preventing movement along this x-axis. We've tried to illustrate this in this diagram. The brace direction resists x-axis movement. Brace direction resists y-axis movement. And so in EnterCalc, you have to think this way because it is the most precise way of defining distance between bracing. The actual distances between braces preventing the member from moving along that axis, which could cause or would cause the failure. Okay, let's save that. Let's go over the steel column program. similar effect. Notice we have the nomenclature here. X-axis effects, Y-axis effects. It looks like this is a very short column, and the unbraced lengths really don't have an effect. So let's kick the unbraced lengths up a bit, up to 20 feet, so we make sure they have an effect. Okay, now we'll just tell it it's fully braced. So obviously, if this column does not have bracing to prevent movement in this direction, which is its most unstable direction, you will get much lower allowable stresses. And in fact, notice the column capacity when it's fully braced. Now notice the column capacity as we give it a 20-foot unbraced length along that direction. We'll go over to the Y-axis, and we should see very little effect. We see a little effect actually. We go from 410 kip capacity, and when we unbrace it along this direction, we have a 289 kip capacity. But nothing compared to releasing it along its weak axis, brings it all the way down to 145 kip capacity. So you'll see our unbraced lengths are measured as the distance between points of bracing that prevent deflection along that particular axis. Similar to masonry, we have the brace directions. I'm not sure if this example is, well, we have a little effect. And then for concrete, similar deal. We have the references in each direction. So I hope that helps you understand some of the slenderness definitions in InterCalc. We get a lot of questions about that way of defining the slenderness, most likely because we are deep into the exact numerics of design and have found over the years that a simple call out of major axis is braced at this, that minor axis bending is braced at such and such. Major and minor axis are relative, especially when you're turning wooden members for minor axis bending. It gets tough. So we use that very simple way of defining brace points as bracing being bracing the column against movement along a particular axis, and that movement is what starts off the tendency to buckle. Hope that helps. We certainly welcome any comments on that subject or criticism of my explanation here to make it clear. And so if you have any thoughts, just contact us at support@intercalc.com. Thanks for joining us.